We're going to do the notes through example 1C on 5.5. It's called the candidate's test for finding absolute, or some books call it global, extremes, which is just the highest and the lowest our functions can be on a given interval. And so let's find our notes and open them to right here. Are you ready, Bella?
Yes, sorry.
All right. So we've already done what's called the first derivative test for finding relative maxes and mins. And we said, well, you have to set that derivative equal to 0, find those critical values, and then make a sine line. And then you can decide whether those provided you with absolute maxes, mins, or neither. So this would have meant the function was going up, continued to go up, and then went down. So right here would have been the location of a relative maximum, right? So with the absolute extrema, you still need to find all those turning points, whether they're smooth or at cusps, but you also have to consider the endpoints. Because a function can be the most it'll ever be at the beginning or at the end. Does that make sense? So you're going to do what's called the candidate's test, which has you do, all I want you to do right here is move that up with an arrow, because I think you'll forget it if you don't do it first. But it starts off pretty similarly. The only difference is we don't make a sine line. So when this says to find the extrema, and sometimes it might just say that, might not say absolute. That means without it there. If they want the relatives, it always has the word relative in front of it. So what you do is you make what's called a candidate table. And you put in values for x, and you see how high and how low the function gets at those values. The first thing I would consider is the endpoints, so you don't forget about them once you start doing the calculus. So that's my suggestion, is you immediately throw the endpoints on the table and see where the function begins and ends on the interval. So you would just do 3 times a negative 1 to the 4th minus a 4 times a negative 1 to the 3rd, and that's going to spit out a 7. So on that interval, this function starts at 7. It may never get higher than that, and maybe that's our absolute max, or it may never get lower than that. It might be our min, it might be neither, but it is a candidate. So then we plug in a 2, then we do 3 times 2 to the 4th, which would be, what, 16, right? Minus 4 times 2 cubed, which is 8. 48 minus 32 is 16, right? I'm not very good with arithmetic, but I would be defeating the purpose if I took out my calculator, because then I could just graph it. So I now know that negative 1 did not spit out the biggest number, right? So the next thing I need to figure out is what happens as I travel from one to the other. Did I ever turn in max out or turn in min out? So all you need to do is take your derivative. This one's a nice, easy power rule just to get us going with the flow of it. So our endpoints go on our table first. Then we take our derivative. What are we going to set the derivative equal to? 0. We need to figure out where it equals 0 or doesn't exist. But the only D and E's come when we have a fraction, and we don't. So I'm just going to factor out a 12x squared, and I'll have an x minus 1. So that's going to give me 2 more candidates on my candidate table. I'll put those on here in black. One of the critical values is 0, and the other is 1. I need to see if the function reached its highest or lowest points at those possible turning places. And so I just plug the 0 in to the original function, and I'd have 3 times 0 minus 4 times 0 is 0. And then I put a 1 in to the original function, and 3 minus 4 is a negative 1. Pretty easy, right? So then what I do is I interpret my table. The absolute highest it got is 16 at x equals 2, and the lowest it ever got on that interval is negative 1 at 1. So if you had to write that out on a test, you would say abs max of. So that the maximum is the y value. It's the absolute highest it goes. So you would say absolute max of 16 at x equals 2. And then similarly, I'm not going to write it out, you guys can, you'd say the absolute min of negative 1 at x equals 1. How's that, Avery? Very doable, right? The only time they get tricky is when it goes triggy. I'm going to show you the graph of that so you can kind of see the confirmation of it. Here's the graph of this quartic function on this interval. And it's telling me that the highest it got was 16, and that occurred at 2, which is what we concurred. And the lowest it is negative 1, and that occurred at 1. So it looks good, correct? Had I made a sine chart, it would have gone negative, 0, negative, positive. Does that make sense? So that one's done. We're only doing 3 of them. It goes pretty quick. So the next one I chose is one where you have to consider where the derivative doesn't exist, because we can have maxes and or mins at turning points like that. So we're going to start off the same way, though. What am I going to put on my table first? The endpoints. Yep, so those are my first candidates. May or may not be the winner for max or min. So I just have to go up there and do 2 times 1 minus, negative 1. 2 times negative 1 minus 3 times negative 1 to the 2/3. Keep in mind you wouldn't have a calculator, so you really need to be sure you know what negative 1 to the 2/3 is. Is it a square root or is it a cube root? It's the cubed root of negative 1, which is negative 1, right? The cubed root of negative 1 is negative 1. So you do the cubed root of it first, and then you square it. So when you're done, you'll have the negative 2 from 2 times negative 1. Then you're going to have minus, right? The cubed root of negative 1 is negative 1. And then when I square it, I get a 1. So I end up with a negative 5. So it starts off at a negative 5. When I put in a 3, watch what happens. I'll have a 2 times a 3 minus 3. I'm just plugging it right up here times. And then I'm going to write this as the cubed root of 3 squared. I don't have a calculator. So I'm going to get that as clean as possible and write it as 6 minus 3 times the cubed root of 9, and I'm just going to leave it. I don't really need to know exactly what it is. I just need to be able to compare it to the others. So if you don't have a calculator, it means it'll be pretty obvious whether it's the smallest or the biggest once we're done. So just go ahead and leave it like that. What's the next thing I'll do? Just to make sure you have the process down, because I'm not doing very many of them. Take the derivative. Yep. So I'm going to go over here, and I'll take my derivative. My f prime will be 2 minus 3 times, and then I'll bring the power out front, and then I'll knock it down 1. I'll clean it up. So I'm going to make it a 2 minus, the 3's will cancel. I'm saying everything because people ask me to record today who are absent, and so if I'm bugging you by saying everything, it's they cancel. All right. Anyway, so I've got what my 3's canceled, and we never leave negative exponents. All right. The next thing you want to do is figure out where the derivative equals 0 or doesn't exist. At this point in your notes, I want you to go like this. Always get it as a single fraction. Because you have to set the numerator equal to 0 and the denominator equal to 0. So when we write it as a single fraction, remember we kind of make sure they're both written as fractions. So go ahead and put that 2 over 1. And then we do the crisp. So the 2 times the cubed root of x. So 2 cubed root x on this minus a 2 all over, and then we multiply across. All right. Now, after Mandy told me to take the derivative, I've got it all there. It's written as a single fraction. I know one of the possible, one of the critical values is 0, because that's where the denominator equals 0, correct? And 0 wasn't a problem, like it's not an asymptote. It wasn't a problem in the original function. So that could be a cuspy. So I'm going to put that on my table. So that takes care of the denominator equaling 0. Then I have to figure out where the numerator, 2 times the cubed root of x minus 2 equals 0. I would always factor so you don't lose answers. So I would always just pull a 2 out like that. What's another candidate for our table? What is it? 1. Yeah, you would need the cubed root of x minus 1 to equal 0, or the cubed root of x to equal 1. So, boom. Now I have 2. The blacks were endpoints. Do you see why I put them on there first? Because sometimes, especially if this gets really long over here, I've had kids in the past, textbooks always say get the critical values on first and then the endpoints, but I always get a couple people who forget the endpoints after they get all the calculus done. So I would do endpoints and then the critical values, and then we're going to go put them back into the, if you're listening to the video, I've tripped. You're going to go put them back into the original function. 0's nice and easy. And then 1 is nice and easy too. So that'd be 2 minus 3, negative 1. Then I'd answer the question, right? What's your question?
Couldn't I do a sine line instead?
No, because a sine line only tells you if things are relative mins and maxes. They don't tell you how high or low they get.
Yep, so couldn't I take those numbers and plug them in?
But that's what would have given you these two, but you wouldn't have had those two. So you do need to have all candidates. So you would forget the endpoints. On a sine line, you never consider the endpoints. You just do the turnings. All right. So anyway, I'll just go back to here. The only number I'm not really sure about is this one. I'm going to circle it. But you don't know the cubed root of 9 without a calculator, but you know the cubed root of 8. What is it? 2. So this is going to be slightly bigger than 2. My guess is like 2.1. This is going to go slightly negative, right? Because you're going to be doing 6 minus 3 times something just over 2. So this is just a little bit under 0. Is it more than that one, though? Do you think it's going to go less than negative 5? No. So that's what I mean. Where if you get one that's kind of messy and you're like, well, I don't know what that is, it'll be easy to compare it to the others. It's going to go slightly negative. So this will be my max right here. And it won't go this negative because the square cubed root of 9 is going to be really close to 2. So if you had to write it out, you would say an absolute min of negative 5 at x equals negative 1. And then you'd say an absolute max of 0 at 0. I'll show you the graph of that while you're writing it out. I'll page ahead here. That's this second graph. Here's our absolute max of 0 at 0. And here's our absolute min of negative 5 at negative 1. Make sense? We good? All right. So then the last one that we're going to do before I send you off to do something else for a bit is example 3, and this one gets really tricky. I kind of thought someone was going to have to Google for us last hour, but I had some math teamers in there who just had a math meet last night, and one of them is, Greta is in the trig portion of it, so she had them all memorized for her meet last night. But there's a trig identity in here that pops up. That if you don't know it, it's okay, but you have to know that it exists. All right, so we're going to start with this. I'm going to hop on here. I'm going to put x. I'm going to put f of x. I'm going to do 0, and I'm going to do 2 pi. I'm going, just so I don't forget about them. They're not critical values. They're endpoints. But again, we just saw in the last 2, I think one each had an endpoint as a winner. So now you need to be 100% sure with your unit circle. I'm going to go sketch it over here because we really need it with this problem, and you need to be accurate with it. All right, so I need to do 2 sine 0, 2 sine of 0 minus cosine twice 0. So let's be 1000% sure. What's the sine of 0? 0. And what's the cosine of 0? 1. So this would be 0 minus 1, 0 minus 1, so I'm at a negative 1. So that wasn't too bad because I'm right on the corner here. And then I'd have to do 2 sine 2 pi minus cosine twice 2 pi. So when it goes tricky, it's going to get a lot more complicated. Like this one actually does get quite complicated, but then we're done. All right, so what is the sine of 2 pi? here. 0. I'm right back. 2 pi is the same as 0. So that's 0. And what's cosine of 4 pi? 1 again. So that's also a negative 1. Those may or may not be the highest or lowest the function ever gets. All right, that's first thing. What's the next step? This is the last time I'm doing it before I send you off to work. We don't need a time. I don't like to waste. What do? The derivative. So we're going to have to remember our derivative rules, but it's not a particularly hard one. So what's the derivative of sine? Cosine. So that'll just be 2 cosine. What rule will I use for this guy? Oopsie. This guy's derivative. Chain rule. Yep. The derivative of cosine is negative sine. So let's make it a plus. And then the derivative of the guts would be 2. You should be doing those really quickly. Here's the problem. I want to figure out where that's 0. There is no place where it doesn't exist because I didn't have a denominator in my derivative. Correct? So I'm just looking for those turning points on that function. If I divided everything through, oops, I forgot my 2x in here. If I divided everything through by 2, I could get rid of the 2. So I'm going to do that just to clean it up. This is where I thought we'd get stuck last hour, but Greta had it in her math week yesterday. So she remembered it. Are you on math team? Are you in the Triggy? So I bet you remember what sine of 2x is? Yes. I thought I was going to have this. Is anyone else on math team? I forgot about you. Yeah, so they had to memorize them, right? So, and you guys did last year for pre-calc. So then somebody last hour said, well, for the AP exam, do we need to know it? And what do you think the answer is? No. They don't want the whole process to fall apart because you don't know what this is. But if it pops up on a worksheet, you might want to at least know there is a double angle formula. Right? And go look it up. But Tristan knew it. So odds are if you're doing a tricky one and you get stuck, you should Google trig identities and it'll unstick you. All right? So what did you say it was? 2 sine x. And you guys haven't done it since pre-calc distance learning, so I didn't really expect anyone to remember that either hour. But now that's helpful because what can I factor out? Cosine. Yeah, I can factor the cosine out. This is going to give me, though, a huge mess to deal with in just a second. All right. So 1000% sure. Where is cosine on my unit circle, which I just erased? So I'm going to go back up here because we're going to need it. On my unit circle, 1000% sure as I travel around it, where is cosine equal to 0? Pi over 2. Yep. So that's another candidate. So let's go over here. That equals 0 at x equals pi halves. I agree with you. Another candidate from my table. Then I'm going to go back up to my unit circle. Where else will I have a cosine on this interval of 0? This, you need to know what that is. 3 pi over 2. If you said, I think I heard a negative pi over 2, that's how you could get there, but you're outside of the given domain. So we're going to say 3 pi over 2. That has a cosine of 0. So let's go add that to our table. So lots of candidates here. Next, this guy could equal 0. And I don't have a calculator, so I know it's going to be someplace on the unit circle. I'd subtract 1. I divide by 2. So I want to see if you guys know or have a way of finding where the sine is negative 1/2. Just kind of do your own little self. I won't walk around and judge you or anything. Just do your own little self-assessment. Do you know where sine is negative 1/2? And if you don't, without Googling, could you figure it out? Like, could you draw a circle and figure that out? The sine has to be negative 1/2. So the y's have to be negative 1/2. So there's 2 more candidates, correct? 1 in quadrant 3, 1 in quadrant 4. Can you find them without looking at anything? Sometimes I worry about our pre-calc or our trig. Did I give you enough time to think it through or no? I just want to make sure I don't care how long it takes you, I just want to make sure you find them accurately. Because actually, they're both winners for this one. So if you didn't find it correctly, your whole answer is going to be off. Do you know? All right, go ahead, Tyler. Where?
7 pi over 6.
Okay, so do you just know it, or did you have to think it out?
I know it.
He just knew it. Who had to kind of think it out? What did you do to think it out, Kristen? Just in case there's people that can't get there.
I mean, I just remember that there's 8 pi over 2, or not 3 pi, square root 3 over 2.
Yep.
And 1 over 2.
Yep, they go together, right?
Yeah.
And they go in this first root 3 over 2, comma, a half, and that's at 1 or pi 6, correct?
Yeah.
So you'd have to go all the way around to get to negative, and then, right?
Yeah.
So this would be pi, or 6 pi 6, and then 7 pi 6.
Yeah.
I'll take it. All right, that's got to go on your table. Go put 7 pi 6 on there. Where else is it negative? A half over here, right? And I wish I drew it a little bit better so it looks like the same. I'm going to take a minute to do that because I think sometimes with the trig it deserves. And we're also going to be negative a half right here. So instead of going forward pi over 6, we could go down pi over 6. Right? Where would that be, Jake? This guy right here. Where the sine is negative a half. Help him out, Joel.
Down there, sorry, I'm looking.
That's okay. You're working ahead.
11 pi.
Yes, 11 pi over 6. That's not calculus, but you still need to know how to do it because we've got to execute the problem. Now I've got to plug all these in. What do I have to plug them into? The original function. I want the highs and lows of the original function. So I'm going to go back up here, and I've got to, again, know my unit circle. What is the sine of pi over 2? 100% sure. 1. Yep, Tristan. So that would be 2 times 1 minus the cosine of 2 times pi over 2, cosine pi. What's cosine pi? 100% sure. Negative 1. Yep, it's over here. So that'd be 2 minus negative 1 or 3. All right, let's go do our next one. Do we need to plug them all in, or do you guys think you can figure it out? I think we could, couldn't we? Do I need to plug them in? Plug in a 3 pi. Let's just do one more. 100% sure what sine of 3 pi over 2? Negative 1. Yep, it's down here. So it'd be a negative 2 minus. And then it'd be cosine 3 pi, which is over here, right? 1 pi, 2 pi, 3 pi. What's the cosine over there? Negative 1. So boom, boom. I'm not going to finish it off. All right, so our next task of the day is you're going to go to Delta Math. There are 5 of them for you to do. When most of you are done with 5, I had a few people that got 4 done in the time when I said that last hour, but when you're done with the 5, move on to your yellow formative until I stop you. So I don't want any dead time, and I think we can finish everything in the class today. So 5 delta maths, there's no trig on the delta math. That's on your worksheet tomorrow. I just want you practicing the process today. So 5 on delta, and then your formative. You should have a yellow if you don't find it. And you'll just do the 5 you want. Alright? And I can monitor on my computer. So when I see most of you guys have.
I have a worksheet.
Yeah.
I don't want to. I think one happened. Thank you.
Yep. Kind of defeat the purpose if you're using a calculator, so I wouldn't. These wouldn't be calculator active. Because if they were, you could just go. Oh, that's right. Yep. Give me 1 second. I need to clean my desk. Goodness sakes. Kristen, do you have the 5354? You were gone yesterday, but I did that completion check on it. You and Isabel.